In this video, we are going to see one of the main applications of Laplace transforms. So that is to solve ordinary differential equations. For solving ordinary differential equations by using Laplace transform, we need these following results. First one, L of y dash of t or L of y dash, because y is in function of t. S L of y minus y of 0. Similarly, y double dash of t, that is L of d square y by dt square. Laplace transform of d square y by dt square. This result is s square L of y minus s y of 0 minus y dash of 0. We can extend this for third order derivative y triple dash. S cube L of y minus s square y of 0 minus s y dash of 0 and y double dash of 0. So we will solve one problem based on this technique. First one, solve y double dash minus 3 times of y dash plus 2 times of y equals e power minus t. Here we are given the initial values. Y of 0 equals 1, y dash of 0 equals 0. So now the solution procedure is, first we have to take Laplace transform for this given equation. That is taking Laplace on both sides. Taking Laplace on both sides. L of y double dash minus 3 times of L of y dash plus 2 times of L of y equals L of e power minus t. Now we know the result as, this is my L of y double dash result and this is L of y dash result. Now I am going to substitute these result here. L of y double dash is s square L of y minus s y of 0 minus y dash of 0 and minus 3 times of L of y dash is L of y minus y of 0 plus 2 times of L of y. Keep as it is. Here L of e power minus t. We know that L of e power minus at, Laplace transform of e power minus at is 1 by s plus a. So here a value is 1. So 1 by minus 1. So 1 by s plus 1. Now in this question itself, we are given that initial values like y of 0 value is 1 and y dash of 0 value is 0. Now I am going to substitute here. Y of 0 value is 1. Y dash of 0 value is 0. Here also y of 0 value is 1. Now s square L of y minus 1 into s, yes, here 0. So leave it as it is. Here 3 times of s L of y minus y of 0 value is 1 plus 2 times of L of y equals 1 by s plus 1. Now simplify further. A square L of y minus s minus 3 times of s L of y minus into minus plus 2 times of L of y equals 1 by s plus 1. Now keep the L of y terms on left side and other term like minus s plus 3 on right side. So now I am taking L of y as common. So what will be the coefficient? Here s square and other coefficient is minus 3 times of s plus 2 equals 1 by s plus 1. Now I am moving minus s on right side. So it will become plus s, positive s, and plus 3 on right side, it is negative 3. Now we can take LCM. S square minus 3 times of s plus 2 equals 1 plus s plus 1 s minus 3. Whole thing divided by s plus 1. So L of y s square minus 3 times of s plus 2 equals 1 plus, now multiply these two factors, s square and plus s square 1 plus s square minus 3s and now plus s minus 3, whole thing divided by s plus 1. Now L of y equals, I will move this quadratic expression on right side, it will come in denominator as well. At the same time s square minus 3s plus s is minus 2 times of s. Here minus 3 plus 1 is minus 2 divided by s plus 1, s square minus 3s plus 2. So here we can make the factors of this quadratic expression. So 2 minus 1 minus 2. Now L of y is s square minus 2 times of s minus 2 divided by s plus 1. We can write it as s minus 1, s minus 2. Now we have to find L of y is nothing but L of y of t equals s square minus 2s minus 2 whole thing divided by s minus 1, s plus 1 and s minus 2. But our aim is we have to calculate the solution for a differential equation. Our differential equation is y double dash of t minus 3 times of y dash of t plus 2 times of y of t equals e power minus t. So we have to solve this equation. So the solution for this differential equation is we have to eliminate y dash y double dash term. So y of t is when this L moves to this operator. This is the Laplace operator. When this Laplace operator moves to right hand side, what will happen? It will become L inverse. So L inverse of 2 times of L s square minus 2 times of s minus 2 divided by s minus 1, s plus 1 and s minus 2. Now as usual we have to calculate inverse Laplace transform for this function. So here we are having several methods like completion of square method, convolution, 1 divided by s, many methods. So out of these several methods for this expression, partial fraction, method of partial fraction is suited for very well, that is partial fraction. I am going to calculate L inverse by using method of partial fraction. Now s square minus 2s minus 2 divided by s minus 1, s plus 1, s minus 2 equals a divided by s minus 1, b divided by s plus 1 plus c divided by s minus 2. Now s square minus 2 times of s minus 2 divided by s minus 1, s plus 1, s minus 2 equals s minus 1, LCM, take the LCM here. So compare the denominator of s and the common denominator, write the excess terms. So when you compare the denominator of a, denominator is s minus 1, here the other two terms are s plus 1 and s minus 2. S plus 1, s minus 2. Similarly for b, denominator of b is s plus 1, additional terms are s minus 1 and s minus 2. S minus 1 and s minus 2. For c, s minus 1 and s plus 1. So these two terms get cancelled. Write the numerator on both sides. So s square minus 2 times of s minus 2 equals a s plus 1 s minus 2 plus b s minus 1 s minus 2 plus c s minus 1 s plus 1. So we have to give values for s. So how can we get the values for x from these factors? So equate the factors to 0. S minus 1 equals 0, value of s is plus 1. And s plus 1 equals 0, s is minus 1. And the other factor is s minus 2 equals 0, s equals positive 2. So we have to give the values, substitute the values of s one by one. First, put s equals 1. So here I am substituting 1 in all the places of x. Yes, 2 times of 1 minus 2. On the right hand side, a 1 plus 1, 1 plus 1, 1 minus 2 plus b 1 minus 1 is 0. 0 into anything 0. Similarly for here also 1 minus 1 0. So 0 into anything 0. Left hand side 1 minus 2 minus 4 is minus 3. Here a 2 minus 1. So the value of a is 3 divided by 2. Value of a is 3 divided by 2. Now put s equals minus 1. So minus 1 the whole square, 2 times of minus 1 minus 2. So here plus 1 minus 1 0, here plus 1 minus 1 0, b. b of minus 1 minus 1 minus 1 minus 2. So from this, value of b is 1 divided by 6. And next, put s equals the same way, put s equals positive 2, we will be getting the value of c is minus 2 divided by 3. Now we have to substitute all the values of a, b and c here. So let it be some 1 and I will take this as star. Now put a, b, c. Put a, b, c in 1 and taking L inverse on both sides and taking L inverse on both sides. So L inverse of s square minus 2s minus 2 divided by s minus 1, s plus 1, s minus 2 equals L inverse of a value is 3 divided by 2 divided by s minus 1 plus L inverse of b value is 1 divided by 6. So this is my b value 1 divided by 6 s plus 1 plus L inverse of c value is minus 2 divided by 3 s minus 2. Now 3 by 2 L inverse of 1 by s minus 1 plus 1 divided by 6 L inverse of 1 by s plus 1 minus 2 minus, this is not plus, minus 2 divided by 3 L inverse of 1 by s minus 2. At the same time from star, this is my y of t. So look at star here. Yeah, this is our star. So this is L inverse of the complete expression value is y of t. This will be the solution for our differential equation, given differential equation. So I am taking here as this expression as y of t. So now y of t is 3 divided by 2 e power t plus 1 by 6, 1 by s plus 1. L inverse of 1 by s plus 1 is e power minus t minus 2 divided by 3. 1 by L inverse of 1 by s minus 2 is e power 2t. So this is the solution for our given differential equation. So we'll see one more problem from this type. So question number 2. Solve d square y by dt square plus 4 times of dy by dt plus 4y equals sin t. If dy by dt equals 0 and y equals 2 when t equals 0. So these are the initial values and this is my given differential equation. So first we have to convert or we have to rewrite the given expression in the standard format. So for this d square y by dt square we can write it as y double dash. So given y double dash plus 4 dy by dt is y dash plus 4y equals sin t. Now as usual taking Laplace on both sides. Taking Laplace on both sides. L of y double dash plus 4 times of L of y plus L of y dash plus 4 times of L of y equals L of sin t. So we know the value of y, this is y double dash. We know the value of L of y double dash. S square L of y minus s y of 0 minus y dash of 0 plus 4. What is the value of L of y dash? S L of y minus y of 0 plus 4 times of L of y equals, we know the value of L of sin at. The formula for L of sin at is a by a square plus a square. So here a value is 1. 1 by a square plus 1 square. 1 square is 1. Now we have to substitute the values, initial values. But in this question itself we are given the initial values. What is the initial values given in the question? dy by dt equals 0, y equals 2 when t equals 0. So let me write, given dy by dt equals 0, y equals 2 when t equals 0. So what is the meaning of this expression? Dy by dt is nothing but y of t, and y is just y of t. So here y of t. At t equals 0, these values are given here. So at t is equal to 0 means y of 0 equals 2. And here, this is my y dash of t. So y dash of 0 equals 2. This is given in the question. Y dash of 0 is, 0. Y dash of 0 is 0. Dy by dt is y dash of t. At t is equal to 0. This is 0. Y dash of 0 is 0 and y of 0 is 2. So here y of 0 value is 2. Y dash of 0 value is 0. And here 2. Now make the further simplification. So s square L of y minus 2 times of s, next one is 0, plus 4s L of y minus, here I am substituting 4s L of y, this is 2. So 4 minus 2, or 4 into minus 2, minus 8. Minus 8 plus 4 L of y equals 1 by s square plus 1. Now s square L of y minus 2s plus 4s L of y minus 8 plus 4 L of y equals 1 by s square plus 1. As usual, keep L of y term on left side. S square, when you are taking L of y as common, the terms are s square plus 4 times of s plus 4 equals 1 by s square plus 1. Move the other terms, that is minus 2s minus 8 on right side. So 2s plus 8. Now s square plus 4s plus 4 equals, taking LCM, 1 plus 2s plus 8 s square plus 1 divided by s square plus 1. Now L of y is one plus 2s plus 8 s square plus 1 divided by s square plus 1, along with this s square plus 4s plus 4. So this s square plus 4s plus 4 can be written as, we can factorize it, 4, 2 into 2. So s plus 2 into s plus 2. S plus 2 the whole square. Now L of y is 1 plus 2s plus 8 s square plus 1 divided by s square plus 1 s plus 2 the whole square. Now if possible, we will try to cancel the terms. So this one is s plus s square plus 1 s plus 2 the whole square. 1 divided by denominator, this term divided by denominator. 2s plus 8, 2s plus 8, s square plus 1 divided by s square plus 1, s plus 2, the whole square. Now, we can make further simplification. S square plus 1, s plus 2 the whole square plus, here if I am taking 2 as common means what will happen? 2s plus 4 divided by s square plus, this s square plus 1, this s square plus 1 get cancelled. So the value is 2s plus 2 into s plus 4, s plus 2 the whole square. Now we have to move with, here we have to do before that this is my L of y of t. So y of t I need L inverse of 1 by s square plus 1 s plus 2 the whole square. And here also the same thing, 2 times of L inverse of s plus 4 divided by s plus 2 the whole square. Now here we can make partial fraction. And here some techniques, because here we cannot use partial fraction, so let me take it as first expression and second expression. Now first expression 1 divided by s square plus 1 s plus 2 the whole square can be splitted into, so this is quadratic expression, so we can introduce a linear expression on numerator, as plus b s square plus 1. Here c by s plus 2 and d by s plus 2 the whole square. Now we have to calculate ABC value. 1 equals as plus b, after taking LCM, as plus b s plus 2 the whole square, c into s square plus 1 s plus 2 d into s square plus 1. So 1 by 1 we have to give the value, only one factor. So when s plus 2 is equal to 0, s value is minus 2. So put s is equal to minus 2. So when s is equal to minus 2, we will be getting here 0 and here also 0, d into 4 plus 1. So 1 equals d into 5. First value d value is 1 divided by 5. So suppose if you are equating the factor s square plus 1 is equal to 0, s square is equal to minus 1, s is equal to plus or minus 8, this is not suitable. So we cannot give imaginary values for s. So next what we shall do, just equating the components. Now I am going to equate the coefficient of s cube. So equating s cube. So left hand side we did not have any s terms. So in the left hand side any s term, so 0. Here s square, here 1 as. So when you are doing multiplication, a times of s cube. So the coefficient of s cube is a. At the same time, if you are multiplying this one, s square into s cube, and the coefficient is c. So next here we don't have any s cube term on d expression. So just a plus c. This is one equation. Let me take it as 1. And next equating s square. Now s square. So s square, if you are expanding this, what will happen? S square plus 4s plus 4. So a s power 3, and if you are multiplying this, 4 times of as into 4s, 4 times of a s square. So coefficient of s square is 4a. And if multiply with the b, and next one constant s term, next b s square, 4bs, b s square, 4bs. So b s square coefficient is b. And another coefficient of s square is, if you are multiplying s square with this 2c s square. So the coefficient is 2 times of c. And here d s square, so plus d. So from this we can get either a is equal to minus c or c is equal to minus c. Now I am going to substitute all the terms here. So 0 equals 4a plus b, 2c. Instead of 2c I can write minus c. So c is equal to minus c. Minus 2a, d value is 1 divided by 5. So 2a plus b is minus 1 divided by 5. This is one of the equation. Next, put s is equal to 0. Put s is equal to 0 or equating constant term. So here, this is my constant term. When you are substituting here, what will happen? When you are multiplying s means as means here as, here as. So here b is 2 times of b. 2 times of b is one of the constant. Yeah, here I am going to multiply 4 times of b. 4 times of b is one of the constant. Left hand side constant is 1. Right hand side constant term is 4 times of b. And next one. So s square, when you are multiplying with the s square, here s cube, here s. So here is, here only 1, 2. 2 into c. 2 into c. And next one, d. What will happen when compare with constant here? This is d square and this is constant d. So this is d. Now 1 equals 4b plus, here also we can write c value is minus a. 2 times of minus a plus 1 divided by 5. So another equation is minus 2a plus 4b is 4 divided by 5. So this is my third equation. Now solving 2 and 3. As usual, we have to solve simultaneous equation procedure. Solving 2 and 3, the value of a and b will be a equals minus 4 divided by 25, b is 3 divided by 25. We know that a is equal to minus c. So what will happen? So c value is 4 divided by 25 and we got the value of d is 1 divided by 5. Now substitute all the values. So L inverse of first expression, we are calculating L inverse for the first term. L inverse of 1 divided by s square plus 1 s plus 2 the whole square equals minus 4 divided by 25s plus 3 divided by 25 s square plus 1. Similarly 4 by 25 s plus 2 plus 1 by 5 s plus 2 the whole square. So for all the terms we have tried L inverse. Here also it is not opening. Yes. It is not opening. L inverse of, yeah, there is only opening. L inverse of, yes, L inverse of, here also L inverse of. Now minus 4 by 25 L inverse of s by s square plus 1 plus 3 by 25 L inverse of 1 by s square plus 1 plus 4 by 25 L inverse of 1 by s plus 2. What shall we do here? S plus 2 the whole square. We have to use the reversal process of shifting property. Plus 1 divided by 5, s plus 2 can be written as e power minus 2t L inverse of 1 by s square. Now directly we can substitute all the values. S by s square plus 1 is cos t plus 3 times of 25 sin t plus 4 divided 3 by 25 sin t, 4 by 25, 1 by s plus 2 is e power minus 2t, 1 by 5 e power minus 2t, L 1 by s square is t. This is the L inverse for first prime. And next one, second phase. What is our second phase? This one. 2 times of L inverse of s plus 4 by s plus 2 the whole square. Now L inverse of s plus 4 by s plus 2 the whole square. We cannot go for partial fraction here. Either we can go for convolution or else any other method. We will solve this by simple technique. Just I am writing s plus 4 as s plus 2 plus 2. That's all. So s plus 2 the whole square. Now L inverse of, I will combine this one, s plus 2 by s plus 2 the whole square plus 2 divided by s plus 2 the whole square. Now 1 time of s plus 2 get cancelled. So L inverse of 1 by s plus 2 the s plus 2 plus 2 into L inverse of 1 by s plus 2 the whole square. Now e power minus 2t plus 2 times of e, here we have to use shifting concept, L inverse of 1 by s square. Now e power minus 2t plus 2 e power minus 2t, L inverse of 1 by s square is t. So this is my y of t. Y of t is equal, this is my second phase inverse Laplace transform. So now our y of t is inverse Laplace transform of first one plus inverse Laplace transform of second one. Now our final answer is just adding both terms of inverse Laplace transform. So the final answer is 4 by 25 cos t, 3 by 25 sin t plus 54 by 25 e power minus 2t, 21 by 5 t e power minus 2t. If you want, I will give one more problem. So that problem is, just I will give the question and introductory part. So because in right hand side we are having two separate functions, 3y dash plus 2y equals 4 times of t e power 3t. So as usual we have to take Laplace transform on both sides, L of y dash plus 2 times of L of y. So 4 L of t plus L of e power 3t. So this is not a problem. Here we have to use the formula. Laplace transform of t is 1 by s square, because L of t power n is n factorial divided by s power n plus 1. So here 1. So 1 by s square. Here 1 by s minus 3. So as usual we have to solve the problem. So now I am going to give the solution for this. So s square L of y minus 3 times of sy of 0, minus sy of 0 minus y dash of 0, y dash of 0 minus 3 into L of y minus y of 0 plus 2 times of L of y equals 4 by s square plus 1 by s minus 3. In the question itself the boundary values are given. Y of 0 is 1 and y dash of 0 is minus 1. So here 1 and here minus 1. So yes, y square L of y minus s minus into minus plus minus 3s L of y, and here 1. So minus 3 minus 1 plus 3 plus 2 L of y equals, here we have to take the LCM, 4 times of s minus 3 plus s square divided by s square into s minus 3. So for this time L of y, L of y, L of y on left side, s square minus 3s plus 2, remaining terms on right side. So 4 s minus 3 plus s square divided by s square s minus 3. So minus s will become plus s, positive 1 will become negative 1. So again we have to do the same process. Before that, here we have to take the factors. Yes, this can be written as 2 minus 1 minus 2. So s minus 1, s minus 2. Now our y is 4 times of s minus 3 plus s square, and here s minus 1, s square, s minus 3 divided by s square, s minus 3, and these two factors are also s minus 1, s minus 2. So L of y is, simplify this numerator, the answer is s power 4 minus 7s cube plus 13 times of s square plus 4 times of s minus 12 divided by s square, s minus 3, s minus 2 s minus 1. Now y of t is L inverse of s power 4 minus 7s cube plus 13s square plus 4s minus 12. Minus 12 divided by s square, s minus 3, s minus 2, s minus 1. So the only one option for finding inverse Laplace here is method of partial fraction. So method of partial fraction. So how can we factorize this expression? Numerator s power 4 minus 7 s cube 12s 13s square plus 4s minus 12. In denominator s square, s minus 3, s minus 2, s minus 1. So a by, first for s square, a by s, b by s square. And for these three factors, c by s minus 3, d by s minus 2 and e by s minus 1. So as usual we have to do the partial fraction method and calculate the unknowns. So I will write the constant directly. A value is 3 and b value is 2, c value is half, d value is minus 2 and the value of e is minus half. Now we can take inverse Laplace transform. So while taking inverse Laplace transform, a value is 3 L inverse of 1 by s, b value is 2 L inverse of 1 by s square, c value is half L inverse of 1 by s minus 3, d value is minus 2 L inverse of 1 by s minus 2, e value is minus half L inverse of 1 by s minus 1. So here the formula are very simple only. 3 L inverse of 1 by s is 1. Laplace transform of 1 is 1 by s. So L inverse of 1 by s is 1 plus L inverse of 1 by s square. Laplace transform of t is 1 by s square. So 2t plus half, these three are same. E power 3t, e power 2t and e power t. E power 3t minus 2 e power 2t minus half e power t. So this is the answer. So